Today's video is on multiplying and dividing rational expressions. So there are two rules that we're going to talk about for multiplying or dividing rational expressions. The first rule that will help us simplify these completely is to factor completely. So we want to factor the numerator and denominator as completely as we possibly can. Then the second thing that we want to know is we want to cancel expressions that appear in both the numerator and the denominator. That's not how you spell denominator. So if I'm going to focus on a couple things, factor and cancel. You will, in class, if you ask me questions, I will often just repeat factor, cancel. So we want to factor as much as we can and then cancel as much as we can. One thing that we need to know is rules on things that we are and are not allowed to cancel. So for example, x plus 3 over 3, we are not allowed to cancel the 3's. That is because 3's are not expressions that occur in both the numerator and denominator. X plus 3 is the entire expression that we have. So we cannot cancel the 3's in this case. We would have to have something that appears as something that's multiplied by the entire problem. So if I have x plus 3 times 3 over 3, I am allowed to cancel these 3's. Also, if I have x plus 3 over 3x plus 3, I cannot cancel anything. But if I have x plus 3 over x plus 3 times x minus 2, I would be allowed to cancel these x plus 3's because notice that this x plus 3 was multiplied by the rest of the denominator. So that's just kind of a quick reminder. And one of the reasons why that's true is if I had something like 4 plus 5 over 5, that would be 9/5. I would not be allowed to cancel off the 5's and make this equal to 4. That doesn't make any sense. So I would not be allowed to do that. That is the reason why we are not allowed to just cancel off whatever we want. Problem 1, we're going to state the domain, and then we're going to simplify. If I'm looking at this problem, the domain of this problem is going to be all of the values of x that I can substitute in. So what I'm going to do first in order to figure this out is I'm going to factor the numerator and denominator. So I'm going to factor this. The numerator is x plus 5 times x plus 3, and the denominator is factored to x plus 3 times x minus 3. So if I look at this, the numbers that I would not be allowed to substitute into this expression would be x equals 3 or negative 3. So that means my domain written in interval notation would be negative infinity to negative 3, union negative 3 to 3, union 3 to infinity. We could also write that. I'll write it over here. The domain is all x where x is not equal to 3 or negative 3. Basically, if I sub in 3 or negative 3, I get 0 in the denominator, and that's a problem. So that's my domain. So I've factored it, and now I'm going to cancel off terms or expressions that appear in both the numerator and denominator that are multiplied by the rest of the problem. Notice that x plus 3 shows up in both the numerator and denominator. So my final answer for number 1 would be x plus 5 over x minus 3. Number 2, I'm going to do the same thing. I will factor this, and then I'll write down the domain. So this is the same thing as x minus 10 over the bottom factors into 2x and x. And then if I kind of look around, it appears that it'll be minus 10 and plus 5. One thing to kind of keep in mind, this isn't a hard and fast rule or anything, but if something shows up in the numerator, it is likely that it might show up in the denominator. We are doing these problems where most of the time things cancel. Again, it's not a hard and fast rule, but most of the time things cancel. So, since that's the case, use what has already appeared as a hint for yourself. So, I'm going to look at number 2. The domain of this is all x except x is not allowed to equal 10 or negative 5 halves, because that would make the denominator equal 0. Notice that my domain restrictions are always related to where the denominator is equal to 0. The numerator is allowed to equal 0, because if the numerator is equal to 0, then the function is 0. But if the denominator is equal to 0, then we have a problem. There is one exception to the numerator equaling 0, meaning the whole function is equal to 0, and that would be for example, in problem 1, if the numerator was, or if x was equal to negative 3, both the numerator and denominator would equal 0. And that ends up being something that is even more crazy. That's called an indeterminate form of something, and that's not so good. So we'll talk about what that looks like graphically in a few days. So again, I could also write this domain as negative infinity to negative 5 halves, union negative 5 halves to 10, union 10 to infinity if I wanted to write it in interval notation. Now I'll take a look at number 2. I can cancel off the x minus 10s, and I end up with 1 over 2x plus 5. Notice that when I cancel things off in a multiplying problem, it doesn't end up being 0, it ends up being 1. Now I'm just going to crank out the rest of these problems to try and help you understand how to do these things. I'm going to factor both the numerator and denominator in number 3. So I have x minus 3 times x plus 3 as the numerator. The denominator is x plus 4 times x plus 1. Notice that in this problem, nothing cancels. I said most of the time things cancel, but I wanted to make sure that there was a problem where you understood that not every time everything canceled. In problem 3, you could write the answer either way. You could write it in its factored form. You could write it in its non-factored form. It doesn't really matter. Number 3, that is our final answer. Nothing cancels off. Number 4, I'm going to factor the numerator. So if I factor the numerator, that ends up being x plus 12 times x minus 4. The denominator, the first thing I'm going to do is look for the greatest common factor, and I'm going to write that on the side because it's hard to do multiple things at once. So 4x cubed is the greatest common factor. So I end up with x squared plus 15x plus 36. So now I want to factor that. So I have 4x cubed in the denominator. Then I have x and x, and I end up with x plus 12, x plus 3. Notice I also have this 2x squared. It's on the side. Anything that's multiplied by something ends up being in the numerator if it's kind of just chilling on the outside. If it was a fraction, 1 over 2x squared, then it would be in the denominator. So this is kind of what it looks like. Now I'm going to simplify everything that I can. The x plus 12s are going to cancel. X minus 4 over x plus 3, nothing can cancel with those. But I do have 2 over 4. 2/4 is the same thing as 1/2. So I'm going to reduce the 2/4 into 1/2. And then x squared over x cubed. X squared over x cubed just becomes x in the denominator. So my final answer will be x minus 4 over x times x plus 3. And then there was a 2 in the denominator also. So it's going to be x minus 4 over 2x times x plus 3. Number 5, there's a lot of greatest common factor and stuff going on, so I'm going to write this in multiple parts. 5 times x squared plus 4x minus 12. And then we have a multiplying, so it's times, and then I'm going to factor the numerator here. So this ends up being 2x and x, and then it's minus 2 over with the x and minus 1 here. If I look at this part down here, there's a greatest common factor of 10. So I have x squared minus 3x plus 2. And then this one, it looks like there's no greatest common factor. But I can also use some other parts of the numerator to maybe help me out. So I'm going to factor this one in a little bit because there's a lot of stuff going on here. There's a 6, there's an 18. So I'm just going to leave this as 6x squared plus 33x minus 18 for right now. Okay, so if I start to factor this a little bit more closely, I have 5 times x plus 6 times x minus 2. And then I also have 2x minus 1 and x minus 2 in my numerator. And then if I look at the back half of this on the denominator, I have 10 times x minus 2 times x minus 1. Now, if I want to look at this 6x squared plus 33x minus 18, the first thing I'm going to do is I'm going to try 2x minus 1. The reason why I'm going to try 2x minus 1 is I already see it in my numerator. It may or may not work, but I'm going to try it because oftentimes teachers make these problems so that something cancels out. So if this is 2x minus 1, this would have to be 3x, and this would have to be 18. So if I have, oh goodness, well, there is a greatest common factor. That would have made it a whole lot easier to factor in the first place if I recognized that. So if I had actually recognized that the greatest common factor in 6x squared plus 33x minus 18 was 3, then that would have made it a whole lot easier. You can blame your teacher for that one. So that's 3 times 2x squared plus 11x minus 6. And yes, that would be much easier. So this ends up being 2x minus 1, which I was going to try anyway. And then I have x plus 6. So all of this ends up working out. That would have been way easier if I saw that in the first place. Notice the x plus 6's go away, the 2x minus 1's go away, 2 of these x minus 2's go away, and then I have 5 over 30, essentially. So that ends up being a 6 in the denominator. So my final answer ends up being x minus 2 over 6 times x minus 1. Number 6. This is our first problem that has division. A reminder, if you divide by a fraction, that's the same thing as multiplying by the reciprocal. So I could rewrite this as 12x squared minus 11x minus 5 over 8x squared plus 2x minus 15 times 8x squared plus 12x over 3x cubed plus 4x squared plus x. So that's something to remember from elementary school and middle school, that when you multiply or when you divide by a fraction, that's the same thing as multiplying by the reciprocal. So now what I'm going to do is I'm going to take each of these and start to factor them. Rule number 1 is factor. Rule number 2 is cancel. It's probably easiest to factor the things on the right. So if I'm looking, I have 4x is the greatest common factor, and then I have 2x plus 3. That will probably help me with factoring some other stuff later. Then I have an x that can factor out of this. So then I have 3x squared plus 4x plus 1. So I'll have a 3x and an x, and then plus 1 and plus 1. All of this will help me with the things on the left. So if I look at this, 2x plus 3 is in the numerator. I'm going to try 2x plus 3 in the denominator and see if this ends up working out. So that would be 4x minus 5. If I did a quick multiplication, the middle terms would be 12x minus 10x. That does end up equaling 2x. So that really helps me. If I look at this 3x plus 1, that's something that I'm going to try first. So 3x plus 1, that would leave me with 4x minus 5. If I try all of this, I get 12x squared plus 4x minus 15x. That does equal negative 11x, and then minus 5. So now I have a lot of things that I can cancel out. 3x plus 1's cancel, 4x minus 5's cancel, 2x plus 3's cancel, and then the x's cancel. So I'm left with 4 over x plus 1 as my final answer. Number 7 and 8 have multiple parts, so I will factor things as I go along. X minus 3 times x minus 5 in the numerator, x minus 3 times x minus 2 in the denominator. Remember, division means it becomes multiplied by the reciprocal, so I'm going to multiply by the reciprocal, and I'm also going to factor x squared plus x minus 30 at the same time. So that is x plus 6 times x minus 5. And then I'm going to multiply by x plus 6 over x minus 5. So notice when I divide, I multiplied by the reciprocal instead. That does not mean that this part gets changed. The x plus 6 over x minus 5 stays the same because that was a multiplying problem. So now I'm going to start canceling things off that need to be canceled off. So I end up with 1 over x minus 2 times x minus 5. That's my final answer. Number 8. Factor the first one, x minus 2x plus 2, 3x squared, there's nothing to factor. I have a greatest common factor of 2x, and that leaves me with 2x squared minus x minus 6. I'm going to factor out an x cubed, and that leaves me with x squared minus 16. So I obviously have some more work to do here. There's still some factoring to be done. And then I have times 9x over x minus 2 squared. Notice that I changed the dividing into multiplying by a reciprocal. If this was off the screen, I don't know if it was off the screen, but that's the answer there. So now I'm going to rewrite some things. X minus 2 times x plus 2 over 3x squared times 2x times 2x and then x. I'll figure out what goes on over here. 2x and x would likely be an x minus 2 and an 2x plus 3. And that ends up working out. Then times 9x, x cubed times x minus 4, x plus 4. And then we have 2 more x minus 2's in the denominator. So now there's a lot of canceling that has to happen. X minus 2 with x minus 2, this x minus 2 with that x minus 2. We have nothing else that appears to be able to cancel in terms of binomial expressions. So now we look at the numerator. That's 18x squared. If I look at this, so 18x squared, and then the denominator is, out of these little solo guys over here, 3x to the 5th. So 18 over 3 ends up reducing to 6, and x squared over x to the 5th ends up reducing to x to the 3rd. So if I do all of that reduction, my final answer, the numerator, ends up having a 6, then I have a 2x plus 3 and an x plus 2, and then the denominator ends up being x cubed times x minus 4 times x plus 4. And that is my final answer for number 8.